didn't.
All right.
So what? Sweden Museum.
Now,
What was it again?
so the last two lessons I've been talking about the probability density function. What we need to look at today is actually the cumulative distribution function. All right. So it's CDF. We look at PDF. So we're going to look at cumulative distribution function now. So you should be able to determine a cumulative distribution function for a continuous random variable and the associated algebraic forms using piecewise definition when necessary. So be able to solve problems in probability, simple, compound, and conditional using cumulative distribution functions of continuous random variables. Understand the integral relationship for the cumulative distribution functions of the CRV and be able to determine a cumulative distribution function from a probability density function and vice versa. All right? So let's start. Let's think about cumulative density function. So we do, if we have a PDF, we should have CDF as well. All right? So a continuous random variable x has a cumulative distribution function, CDF, where fx, I use capital Fx, is a probability less than or equals to x. So you know that it is cumulative from one point to the other, which can be used to describe the likelihood of from the lower bound of the PDF up to and or including a particular value of x. All right? So think about it. Fx is the probability of x less than or equals to x or less than x because they are basically the same continuous random variable. And you are actually doing an integral from ft to dt. All right? Think about it, link that to the fundamental principle of integration. All right? T is just a dummy variable of x. So now let's think about calculating a cumulative relative function. Frequency, not function, using a table. So you should know how to work out the relative frequency, and cumulative frequency is just keep on adding. All right? So you add, keep going, that's the frequency, you keep on adding, 2 plus 7 equals to 9, 9 plus 7 equals to 32, and so on and so forth. So therefore, cumulative relative frequency, you should start thinking about this. So it's 2 divided by 100, 9 divided by 100, because I've got 100 samples there from memory, or you can just use 2 divided by 100, 9 divided by 100, so on and so forth, rather than adding those two together. So you can actually work out the cumulative relative frequency as well as the cumulative frequency. Now, notice something. With cumulative relative frequency, when you add it all up, the n is always 1, because it's 100 divided by 100, or what is the sum? Sum divided by sum. The total sum divided by total sum. So in this case, I'm looking at this example, which was from a couple of weeks ago, 3 or 4 lessons ago. We talked about 100 samples, so just using the same example. All right? So you should be able to work out the cumulative frequency as well as the cumulative relative frequency. So work out the cumulative frequency first, or work out the relative. So you can see that this is keep on adding up. And towards the end, it cannot be greater than 1, it cannot be less than 1. It has to be 1. All right? So if I plot a cumulative frequency curve, it is often graphed as a line graph, or this shape here is called an ogive. And for the data in the previous slide, the ogive is actually something like this. And you can see that the starting cumulative relative frequency should always be 0. And the end, the cumulative relative frequency should always be 1. Keep on adding up, all the way up to the end. All right? So from 0 to 1. Now, so if I look at something like this, a uniform distribution, you know that fx is 0.2 from 1 to 6. Alright? And it's 0 from all other values of x. So what we're going to look at is this part here.
Yes.
Alright? So, first, is this a PDF?
Yes.
Why?
Because the area under the graph is equal to 1.
Thank you.
And
what
then
about the other
everything is
condition?
greater than 0. All x's
Yeah,
are greater than
everything's
0.
greater than 0 and the area under the graph is 1. So you
Awesome.
do know that this is
I
a
just cranked my knees.
PDF.
Look,
Alright?
I just
I'm
hit a
pretty
90%.
sure I've seen questions which ask you to actually determine whether something's the PDF is valid. Alright, so you must test for two conditions.
Yep.
So now if I let k be any value within the domain 1 to x. Alright? So anything, it doesn't matter. So from here to here, if I want to look at the area, it's actually k minus 1 times 0.2. Correct?
Yeah.
Yeah? So we know that the CDF, the function of CDF, capital Fx, will be such that Fk gives the probability that x will take a value less than or equal to k.
Yeah.
So it's cumulative, so this is addition. Alright? So that's what you need to know. Now, we can do it two ways to determine P of x less than k, by calculus or by area of rectangle. So let's think about it. If you go back here, you know the area is the 0.2 times k. Alright? You can do that. Or if you want to do calculus, it's from 1 to k. So let's start off with calculus. Alright? Oh, that shouldn't be out there first. Let's do the calculus first. So, let's have a look at the calculus. So I am actually integrating from 1 to k. That area there. Alright? And you know that this is 0.2.
Oh, never mind. Isn't it? Is it dk? Not dx.
No, dx.
Is it
The x. It is the x.
Ah.
Because it's x.
Oh, yeah.
It's x. Alright? So therefore, you know that 0.2x from 1 to k. And the area there should be 0.2k minus 0.2. Alright?
Yeah.
Or put it this way, 0.2k minus 1. Alright? So, if I do the area of rectangle, it's basically the same thing, k minus 1 times 0.2. So 0.2 times 1. So now, how do we actually write the cumulative distribution, capital Fx, for the uniform probability distribution? Alright, it can be expressed as a three-part piecewise function. So part 1, part 2, part 3. So anything less than 1, the probability is 0, correct? There's no area at all. Alright, now let's keep going. So between 1 and k, what you need to do is substitute x in there, because there could be any value, could be any x there. So substitute x instead of k now, write it down as 0.2x minus 1 for the domain between 1 and 6. Alright? Now, as soon as you hit here, that's 1, area of 1. Anything above that, the area is still
1.
1. So therefore, this is how you write out a CDF. Piecewise function, 0, and then whatever the function is here, and then anything above that is 1.
So you change it
Alright?
from k to small x?
Yeah, you change k to small x, that's all. Because it could be any value of x.
Oh.
Alright? So I'm just using this to show you between 1 to k, but when you're actually doing it, it's any value of x. Correct? Yes?
Will we be asked to draw it?
Sorry?
Draw that or not?
It depends on question. You might be asked to draw it, you might not
If we
be.
draw it, would you want us to do it?
Oh, this one, yeah.
Because it's
CD.
not actually a function when you draw like that.
Yeah, it is a function you can draw like that. It's a piecewise.
It's called a piecewise
The sides
function, mate.
are aligned.
Sorry?
Like the sides are aligned so that it would fail the vertical line.
Oh my god, bro.
You don't seem to use dotted
No.
They're supposed to be
That's
dotted,
not
mate.
not a vertical line. That's because you can't. It is a function because it
They're
does
dotted.
not. Okay. So when
They're
you
dotted
draw that,
lines.
there should be.
We're thinking too hard.
it does include this point, but this point is included. It's that point. That's how you do it. So it's not actually
If you drew a dotted line or just
Dotted
Sorry?
line.
yeah. Because this point is not included. That point is included. So therefore it's not. All right. It is a function. All right. Next. So now to generalize it, the CDF of a CRV can be written as a piecewise defined function, which includes a 0 case and a 1 case. So starting off from anything less, if it is between the bound of A and B, so anything less than A is 0, anything above B is 1. Now here, you could have 1 function, 2 functions, or 3 functions. You may have situation that the whole PDF may look like this. Alright, or something like this. Alright, the PDF may look something like this. So this is A and this is B. So you may have a non-linear, and then a linear function like this.
Or just
As
noise.
long as the area under this is 1, it could be a PDF.
Yeah.
Alright? So here, it's not just 1 function, you can have 2 or 3 or 4 functions. Alright? So there is a connection to the fundamental theorem of calculus. So the PDF of the CRV is the derivative of the CDF as long as the derivative exists. Alright? So think about it. You are, the PDF is a derivative of the CDF. You are integrating the PDF to get a CDF.
Yeah.
So therefore, work backwards. The derivative is the derivative of the CDF is the PDF. All right. Now, let's have a look at something like this. So given that a function, the CDF, f of or function or capital F function of x of px less than or equals to x is integrating from a to x, f d dt, and the bounds of the PDF are a and b. Can you deduce the following? What is the probability of x less than a?
0.
0. All right. Very good. Oops. Why did I do that? Okay. That was a drawing. Yep. Okay. So that is 0. All right. So you know that just sketching that out. So next thing, if it is greater than a, what happened?
1.
It's 1.
It's 1 because it's 1. Take away that. Therefore, it's 1. What about between a and b? Has to be 1.
Is it 1?
What about less than b?
1.
Has to be 1 because the area is 1. Anything down there is 0. Greater than b?
0. Yeah.
Is 0. Because 1 take away that is 0. But if you've got something like b plus k as a positive real number, it's actually equals to 1. Alright? So think about that. 1 take away that
Oh, yeah.
is 0. But if there's b plus k or whatever,
Because it's less than
it's 1.
anything less
less
than
than or
b
equal.
plus anything will still be 1. Because all of the area is below.
Anything greater, because it doesn't include that, is 0, correct? Yeah? Think about that. Anything greater, this is 0.
Yep.
That's 0, that's 0.
Yep.
But it's less than or equals, because that includes that already, therefore it's 1.
Wait, so
Yep.
for the third one,
Symmetrical.
how is
Yeah.
px less than
Wait, what's the
a
mean?
equal to fa?
Function of b, take away function of a.
Wait, that's not PDF though.
This is a CDF.
Oh,
No, this is a PDF.
Oh, it's f.
Yeah.
How?
Oh,
Right?
Look, it
All
says
x values have to be positive in a PDF.
Alright,
no, they
next.
don't. They can be 0.
So example 1. Going through lots of
It's a
examples
negative
now.
1, bro.
Determine the CDF for the following PDF,
No, all
and
the y
hence
values have to be
use the
greater than
CDF
zero.
to
Not the x
evaluate
values.
between between 1.2 and 1.4. Now, this is a triangular
True.
distribution.
No, you're right.
So what you need to do is look at the PDF. You need to work out this equation. What is the equation of that line? First, gradient. Correct?
2x
What is the gradient?
minus 1.
Oh,
Yep.
shit.
So for the equation of the line between 1 and
That's
2,
fine, I think it's fine.
m equals to 2, and therefore y equals to 2x plus c.
I think it's fine.
But what you could do is substitute one of the numbers in. When y equals to 0, x equals to 1.
Yeah.
So therefore c equals to
minus 1.
minus 2. And the equation of that line is y equals to 2x minus 2.
How's it minus 2, bro? Oh, yeah.
Do it step by step.
Isn't it? F of
So now you've got y equals to 2x minus 2. Between them. Alright? So you can write up fx, the PDF function, which is 2x minus 2 between 1 and 2, and then 0 elsewhere. I do like to write that down so I know what I'm doing. So I know the bound that I'm looking at, which is between 1 and 2. So you know that the CDF, anything less than 1 is 0. Anything greater than 2 is 1. Right?
Cumulative. Yeah, distribution function, not density. My bad.
So now, what we need to do is, how do we find the area? So I have probability of x less than or equals to k, between 1 to k. I'm integrating this because I'm looking at the area. It's 2x take away 2. Yeah? 0 to k dx. So therefore, we know that it's if I take the 2 out, it's x squared, x minus 1 squared, 0 to k, and therefore it's k minus 1 squared. Alright? Work it out as k first or t or whatever. Use a dummy variable first. Alright? Once you have done that, you could write down your
Isn't it just
CDF, capital Fx. So capital Fx, anything less than 1 is 0. Anything greater than 2 is 0. So between 1 and 2 is x minus 1 squared.
Yep.
Alright? Anything between 1 and 2 is x minus 1 squared. So if I want to find out between 1.2 and 1.4, I need to actually use this area, 1.2 and 1.4. You want that area. So it's this area. Take away this small area there. Alright? Yeah? So you know 1.2 is here. This is 1.4. So you've got a bigger area. Take away a smaller area. Alright? So you've got the you've got the trapezium here.
Oh,
Yeah.
yeah, true.
So it's f1.4, take away f1.2, and working that out should be just 0.12. That's a probability between 1.2 and 1.4.
So,
Yeah?
isn't there shouldn't there be a 1 there? Because when you sum in the 0, this
Where?
is 0 minus negative 1 squared
Where? Which one?
at the bottom. The
So k here, but then, hang on. X minus 1, k minus 1 squared, plus, okay, write that down.
Oh wait, sir.
No, it's
Supposed to be from
zero.
1
Yeah,
to
it's
10.
from
It's
one.
1, it's not 0, that's 1.
From 1.
Sorry, that's from 1.
yeah, it's gonna say.
That's from 1. My fault, that should be 1. My fault.
Yeah.
I don't know why I wrote down 0, that should be 1.
Right,
Alright?
actually just
I'll sort that out.
just correcting the teacher and that.
1. It is
Yeah.
1.
That girl, man.
You're just that kid, bro.
Yeah, it's just 1. It is
100%.
correct. It's my fault, it's not
100%.
0. When I wrote down, it's
Actually,
not
not
0.
physics. He told me.
Alright?
Bro's popping off.
So do it step by step. You can see that the cos is
Nah,
everything
we'll just
split.
solve it by area, bro.
Oh, that's too cold, bro.
Just like so I can like spend more time. Otherwise, I just go through the test too quickly.
Oh, yeah.
Alright, let's move on. Next. So example 2. Determine the CDF for the following PDF and hence use the CDF to evaluate x is greater than 2. So you know that you need to do an integration
Yes.
between 0 and 5. So I'm just going to use, this time I'm going to use x because I'm using a fundamental theorem of integration. So here, if I do it that way, straight away I know is x cubed divided by 125. So I can write down my CDF. So capital Fx is 0 when x is less than 0. It's 1 when x is greater than 5. Those two are given, but you need to be able to derive that. Alright? So it's between 0 and 5. So if I want it to be greater than 2, it's 1 minus x less than or equals to 2. So use the complement. If it is greater than, it's 1 take away, x less than. Use the complement, and it's 1 minus f2, and you can work that out. It's 117.117 over 125. Or you can use your, now with probability, I recommend that with probability, if it is a calculator assume section, 4 decimal places. Alright? 4 decimal places so that when you actually write in percentages, gives you 2 decimal places. Alright, suggestion? For probability, always give 4 decimal places.
Yeah. Unless said otherwise.
That's right. But I will use 4. Alright, next. Now, you need to determine the CDF of the following PDF and hence use the CDF to evaluate probability between 5 and 10. Now realize that if it is E, the upper bound is actually negative. It's infinity, not negative, it's infinity. Alright? So for E, the upper bound is infinity. And you need to use your class back to do integration infinity.
Ooh, difficult integration.
Differentiate that. You should know how to differentiate your E.
Yeah.
Alright, and you get something like this. So E to the power of 0 is 1. So minus minus is plus, so it's become the whole CDF is just 1 minus E to the power of minus 0.5 x. Right? Happy with that so far?
Wait, sir,
Yeah?
shouldn't it be 0 for x is less than 0, and then that for x is greater than or equal to 0?
Sorry?
Shouldn't the CDF be a piecewise?
Yeah, but I'm just integrating the area and so on. I haven't written that one out yet.
Right, yeah, okay.
I haven't written that one out yet. So this is like this.
Yeah.
Isn't this just a double piece?
Yeah.
Then you write the CDF out.
Yeah.
I haven't written the CDF out. So you could use P of x less than x or capital Fx. It doesn't really matter. So there's a piecewise function, and therefore it's F10 minus F5.
dx.
Yeah. And evaluate that.
You gotta use dummy
0.0753. Now integrating that.
Just use dummy variable.
Use a dummy variable, use a fundamental theorem of whatever. Fundamental theorem of calculus. Alright? 4 decimal places because it's probability.
That's why he's the GOAT.
Alright, next example. Happy? I'll go on. Here, determine the CDF for the following PDF and hence use the CDF to evaluate that.
Integrate it. It's just sign.
I'll let you integrate. Now here you can see that it's from minus pi over 2 to 0. So is this a proper PDF?
No.
Why not?
No. I'll just wait. Yeah, no, it is.
It is because
Yeah.
cos x of negative pi is positive and pi over 2 is positive.
Yep.
So it's in the fourth quadrant and fourth quadrant is positive.
Yeah.
Cos is positive.
Wait, out of 10, how hard was the physics?
So
Okay.
what you need to do is integrate from minus pi over 2 to x cos t dt. And then you know that it has to be that and it's sine x plus 1. Alright? Just remember d dx sine x is cos x. So integrating cos x will be sine x. So sine of minus pi over 2 is minus 1, minus minus is plus. So sine x plus 1. And therefore write out the CDF. Alright?
Let's get this crown.
So if x is less than minus pi over 2 is 0, between minus pi over 2 and 0 is sine x plus 1, and x greater than 0 is 1. Alright, from there you can think about how you work out y equals to x less than minus pi over 4, probability of x less than minus pi over 4. Just substitute in there, and therefore that's okay. I don't have to evaluate that. Alright, if this is calc free, don't have to evaluate that. If it is calc assume, evaluate that. I mean, I'm happy enough if you give me the answer there. I just make it a little bit neater, that's all, that way. Alright?
Bro, why do you keep on pushing the camera, bro? Damn.
Now it's gonna be.
Alright, last example.
That's it.
Oh, two more examples. Example 5. Now here, you can see that you've got to determine two linear equations, correct?
Yep.
And you should be able to realize that the m, one is the gradient, one
So
is
just x.
1, the other one is minus 1.
X plus 1 minus x plus
1 and minus 1. Alright? So you've got the situation between minus 1 and 0, the equation is x plus 1. Between 0 and 1, the equation is minus 1 plus x. And then 0 everywhere else. That is your PDF. Alright? Probability density function. And therefore, for between minus 1 and 0, you can do the integration. You need to integrate twice. Between minus 1 and 0, and then 0 and 1. Alright? So integrating. You get something like this. Alright? Yeah? Alright? Happy enough with that? So once you've done that, this is what you're going to write it out, the CDF. Now, when you look at something like this, you know that this is symmetrical, correct? So therefore, the area here will be 0.5, the area there would be 0.5.
Yep.
Symmetrical. It cannot be anything else. The whole thing is 1, they're going to be 0.5, they're going to be 0.5. Yeah? So you can see that area is 1. Half of 1 times 1, that's half, 0.5. Half of 1 times 1, that's 0.5. Just looking at a question like this, remember, if it is symmetrical, that has to be 0.5, that has to be 0.5. Although in this case, we are not really applying it to here. We are looking at 0.25 to 0.75, which is that area. All right? Yeah?
Oh yeah, just add it. Oh yeah.
All right. So we could
Wait.
use the information.
Wait, 0 to x.
Sorry?
So it's going to be 0 to x, right?
0 to x, yeah?
Yeah, like for the integration.
Yep.
Negative 1 to 0 plus 0 to x.
Hang on. 0 to x is that bit here. All right. You've got 2 equations there now
Yeah,
for the area.
like this part of the integration. Like it's definitely x.
Oh yeah, it is x.
Ooh.
Hang on. Let me think about.
Yeah.
Because then that would just be a number.
Yeah, it'd be equal to 1, right?
That would just be a
Yeah. That's right. So yeah, that should be x. That's correct. Yep. That's correct. Yep. So that's correct. So I'll sort it out. Yep, my fault. So once you've done that, you can work out between 0 to x less than 0.75, take away x less than 0.25. Alright? So x, that's how you do it, and therefore, oops, your answer is, I don't even know what I wrote it down.
What is that?
11 over 16. Alright, 11 over 16.
Bro, why are you doing this monkey guy?
Alright, last one is an interesting one. Last one, you're given a CDF. You got to come up with a PDF. Alright, so I've given you the answer. Can you actually think about how I derived the answer?
Yeah.
I've given you the answer.
Just differentiate.
Yep. So you need to be able to differentiate your CDF to get your PDF. So try that and see whether you get the same answer as I do. You should get the same answer, because if you differentiate 0 is 0, differentiate 1 is 0. The rest you should be able to differentiate.
Yeah. Easy diffs. Yeah, you just diff, bro.
So differentiate x plus 1 divided by 3 is 1 x over 3 plus 1 over 3. So it's therefore it's just 1/3.
3 x squared.
Alright, and sketch that please. Yeah, just derive, because CDF back to PDF is derived. Because PDF to CDF is integrate, so CDF back to PDF is just
Easy.
derive. Yeah, it should be pretty straightforward in this one. Alright? So yeah, if you integrate 0 and 1, it's just 0. Sorry, not integrate, differentiate. So can you sketch that? So what you need to do is sketching that. Work out approximately where all the things are. And then what I did was, I have a dotted line up there between the bounds, -1, 1, and 5. 0 I don't need because the axis is there. So then I can draw those two. Remember, that's open circle, because does not include that point, does not include that point.
Have enough.
Alright, and then
Hungry point.
next one is 1/3.
Oh.
It's a straight line 1/3. Doesn't include that. Read that carefully. And then here, all the way up x squared. At least draw something like resemble a parabola, alright? Not a straight line.
Yeah.
So you need to have a little bit of curve. Therefore, I actually show this. So it actually looks like, correct? And then that line and that line. So please
without.
make sure that you follow that carefully. All right, so that's
Yeah, mate.
fill in, but that's
Yeah,
open,
mate.
open, open, and open.
See that
Circle.
photo next
All right.
time. No,
Now I'm going to stop
said
here.
words.
There should be plenty of exercises for all of you to do.
It's piecewise, so it's different.